In this problem from JEST 2021, we are given a Lagrangian. We have to identify the correct set which represent the Hamilton's equation of motion. In order to solve this problem, we can first convert Lagrangian to Hamiltonian, then use the Hamilton's equation of motion, which are q I dot is equal to del h upon del pi and pi dot is equal to minus del h upon del qi. This is one way to do this, but when we are using this method, we have to use two steps. In the first step, we have to convert Lagrangian to Hamiltonian, and in the second step, we have to use the Hamilton's equation to get the correct set. The second method is using the relations del L upon del Qi dot. This is equal to Pi. This is the relation for generalized momentum. The second relation is Pi dot is equal to del L upon del Qi. In the first option, we have mx dot is equal to 2py. Let us check if this is correct or not. Py is given by del L upon del y dot. L is 1 by 2 mx dot y dot minus 1 by 2 m omega square xy. Therefore, del L upon del y dot is 1 by 2 mx dot. From here, 2py is equal to mx dot. This relation is correct. Mx dot is equal to 2py. D option is not correct because mx dot is given to be py, which is not correct. Now let us check the second relation. Px dot is equal to minus 1 by 2 m omega square y. Here we can use the relation Pi dot is equal to del L upon del Qi. Pi dot is equal to del L upon del Qi. We need Py dot. Py dot is equal to del L upon del y, which is equal to, from here, del L upon del y is equal to minus 1 by 2 m omega square x. Therefore, this relation is correct. Py dot is equal to minus 1 by 2 m omega square x. Now let us check Px dot. Px dot is given by Px dot is equal to del L upon del x, which is equal to minus 1 by 2 m omega square y. Therefore, this relation is also correct. Now the last relation for Px. Px is given by del L upon del x dot, which is equal to 1 by 2 my dot. This implies 2px is equal to my dot. Px is equal to my dot. The correct option here is option A. Now I suggest you to do the same problem by converting Lagrangian to Hamiltonian and then using the Hamilton's equation of motion. This will give you a practice. I have already done a video on how to convert Lagrangian to Hamiltonian. I will put a link in the description for that video. More PYQ solutions are on the way. Make sure that you are sticking around the channel. Let's crack those exams together. Thank you. See you soon.